All right, let's get started then. Have a seat, relax. I'm going to share and I'm going to ask that question. Can you see my slide? I think you can now.
Yes.
All right,
Yes.
excellent. All right, let's move forward here. Okay, I have a little clock here too, so I'll do my best to stop right when the big hand gets on the 9. I'll keep an eye on it. You keep an eye on it too. Tell me if I'm going too long. Okay, so first of all, I'm over here on the left, over here in California, in the Bay Area, San Francisco Bay Area. I was born in upstate New York, got my electrical engineering degree in Cleveland, Ohio. Beautiful place to go to school, but not to live long term. I retired. I was in big companies, small companies, really had a lot of fun in my career, especially in startups. We've got 5 grown kids and 6.5 grandkids now. I just have fun playing golf. I'm a bogey golfer. That's 1 over par. So I have a lot of fun. But I do love to hike a lot here in the California foothills with my ICOM 705 QRP radio in my backpack. I do a lot of music, recording, playing, all kinds of fun things. But, to be honest with you, I'm kind of a geek. I love POTA. I love Parks on the Air. As an electrical engineer, I just been always fascinated with antennas, and that's what we're going to talk about tonight. I've done over 1,000 activations since January of 2021, I think is when I started. And even though I passed my 20 words per minute back in the 90s to get my extra, I'm kind of a talkative guy, so I do a lot of sideband, 85,000 sideband QSOs on POTA, of which a lot of them are me testing antennas, and we'll talk about that. Okay, so first of all, not that you're going to take notes, but if you're thinking about it, you really don't have to, because everything I'm going to talk about, everything, including the slides, they're a subset of my antenna primer one, which I'll mention in a moment, but all of my antennas, and I have about 10, 11 of them now, with about 3 or 4 more coming out later on this year. These are all homebrew antenna designs, and I'm always going to share them for free. When it comes to the economy, I'm a capitalist, but when it comes to ham radio, I'm a socialist. I believe in giving things away because I want the greater collective, the wisdom to continue to rise year after year, decade after decade. My dad taught me that, and I keep doing that even now to this day that I'm retired. So everything I share is going to be for free. You'll never have to pay for it. I don't believe in that. But I got all my antennas there. I got a lot of educational material that I put together, some primers. I have a monthly newsletter. So if you're a geek like me and you like to read about homebrew antennas, which by the way, that is our last frontier, homebrewing antennas. So don't just ignore it. Get your hands dirty, build an antenna. It's so much fun. I got an Antenna Geek email list, so feel free to join that. And I only send you one email a month about. So plus there's an archive of all my other newsletters there. So by all means, check it out, KJ6ER.net. And I also answer all my emails the following morning that I receive them over my 2 cups of Italian dark roast coffee. So I get energized over that. So Greg at KJ6ER.net. It's just my call sign.net. My name, Greg. Don't worry about my last name. You can't pronounce it anyway. All right. So I do like to educate, and I put together a couple primers. The subset, well, the slides I'm showing tonight are a subset of what's in my antenna primers one. And what I basically did back in 2019 and 2020, I started curating research because I wanted to build my own antenna for Parks on the Air portable antenna. So I did a lot of research and I learned a lot, and I got exposed to a lot of very intelligent people, and I'll share some of that research tonight. That's really Antennas Primer 1. And then in Antenna Primers 2, I walk you through the entire antenna system efficiency from your transceiver, I love the ICOM 7300, to the transmission feed line with SWR, as well as the antenna structure, which is antenna gain, directivity, and radiation efficiency. So if you're interested in that kind of thing, or you just want to kind of get those neurons working inside your mature head, by all means, take a look at the primers. They're free on my website, KJ6ER.net. All right, well, this all kind of really kicked off about a year and a half ago. The ARRL QST was having an antenna design competition, and I wasn't even aware of it. And then a few of my buddies, a couple of the hunters at POTA, as a matter of fact, as well, said, you ought to submit your antenna, the Performer. We'll talk about that one tonight, the Performer, and it's my elevated quarter wave with elevated quarter wave radials, two of them. And lo and behold, I had to send in my computer model, which I put a lot of work into. I put in dozens and dozens of hours of testing in my backyard, but I also used it at POTA for a couple, 3 years and learned a lot about how to deploy it efficiently. So I sent that all to the QST magazine and found out within a couple of months that I won an award. And I was quite proud and quite honored by that. I wasn't expecting it, so I was really pleased to get that. And part of that award was they took I have an 18-page PDF for you free of charge to look at if you want to build the antenna. It's on my website. They took that and worked with me to get it down to a 5-page article. So I can now get an article in QST magazine off my bucket list. That happened last September, as a matter of fact. And they saw one of my previous newsletters just about 3, 4 months ago, and they turned that one into an article. So I'll get another article next year about the solar minimum. So a lot of good stuff is coming out, and I'm really enjoying my relationship with the ARRL. They're our lobby, so we got to support them. And then another surprise in December. I didn't realize they even had this, but I guess people can vote on their favorite article in every magazine. And lo and behold, the Performer article won. That was in that magazine, September 2025 issue. So I was proud of that as well. Didn't expect that. Very proud. Okay, so what do I do? Well, like I said, I started in 2020 because I went out to POTA. I didn't want to spend five, six, $700 on an antenna system that I'm going to play with in the park or throw into my backpack. So I decided to design my own, and I didn't call it the Performer initially. I just called it my POTA antenna. And then after I started using it with a lot of hunters over the first 6 months, they kept saying, "Wow, you're the loudest signal on the band. How much power are you running?" I said, "I'm just running 100 watts." But they said, "Boy, you're the only signal I can hear," or "My goodness, I'm really impressed. Send me the plans. I want to build my own version of your antenna." So I had to come up with a name. I like names. It's fun. Ham radio's fun. Let's not take it that seriously. So I called it the Performer, and we're going to talk about that one tonight. But since then, I'd like to go inside of these deep, thick, expensive antenna books with all these articles about antennas that have been around for decades, but they're not written for the every ham. And I believe in everything should be done in terms of the every ham. So I take a look at some of these classic antennas, I redesign them, I simplify them, and I make them portable. And we'll talk about that in just a moment. And I'm always sharing the plans for free. Again, I don't believe in putting these in a book and selling them. I think you should have these for free. So when I came out to Silicon Valley from Ohio, I sat about 50 feet away from Bill Hewlett and Dave Packard at HP. They were legends. And they were alive and well and running the company. That was the classic HP, the HP that I grew to love after being there for, oh gosh, 15 years, I think. But Bill Hewlett, he told us engineers, if you want to design something, you got to have design objectives or design principles. And then Dave Packard added that they have to be measurable, because if you can't measure them, how do you know if you've achieved them? So I came up with 3 design principles, and I've been using these same principles along with every antenna that I have been sharing for free. The first is always focused on performance. I figure, I got to differentiate them somehow. So let's focus on performance, but let's focus on something that the commercial manufacturers never spec or rarely spec. They don't talk about it because it's not as good as you might think. It's called radiation efficiency. It's one of the two antenna gain is equal to directivity times radiation efficiency. Directivity kind of reshapes, reconfigures the radiation pattern. Radiation efficiency tells you how much of your power that's applied to the antenna is radiated in the air versus how much is actually turned into heat. So the higher the number, the better. We'll talk about that. So I only focus on highly efficient and effective antennas, always resonant. I don't want you to use a tuner. You don't need to use a tuner. It's just another thing to carry. It could have a little insertion loss. They're usually pretty good about that these days, but they're always resonant, and they're always going to be one band at a time because I want to preserve this beautiful radiation pattern, the impedance that I put together, and also the radiation efficiency. So 90% efficiency or more, meaning that if you apply 100 watts, you're going to radiate at least 90 watts. Now, if you think, well, that seems reasonable, most antennas you buy out there are 50%. 50%. So this is almost double that. We'll talk about that. So performance, number one. Number two, these are portable antennas. Now, I originally thought of them purely as portable antennas, but then I found out there's a whole group of people, quite a few, thousands, a matter of fact, that wrote me over the last few years that live in HOAs or restricted neighborhoods. They can't put up big antennas, so they want to put up a really good antenna quickly in the backyard after dinner, play radio for 3 hours, and then take it down before the neighborhood marshal sees the next morning. So not only are they portable, but they're for HOAs and other restricted places. Fast and simple deployment. I call that elegance because if you design an antenna with less parts and pieces than a really complicated esoteric one, it's going to be very elegant. It's going to be simple, less parts and pieces to put together, take down, deploy, whatever. Oh, someone's got to mute because I hear an echo. Mute. If you're not on mute, mute. There you go. Thank you. Elegance, number two. And number three, again, because these are portable antennas, primarily convenience. I want them to be easy to pack and easy to transport. I don't want you to, reserve a huge corner of your garage for all these antennas and these parts and pieces. I want to make it simple. You can throw it in your trunk, put it in your backpack, which I love to do. Picnic table activations, as I mentioned, HOA. I call that convenience, easy to pack and transport, 5 pounds or less. So the three design principles, and Bill Hewlett would be proud that I'm continuing in his tradition of doing that. Performance, number one, 90% efficient. Elegance, number two, 5 minutes or less to set up or take down. Convenience, easy to pack and transport, 5 pounds or less. Simple. It's pretty straightforward, I hope. Okay, well, so this started, I started sharing antennas about 3 years ago. And since then, 120,000 PDFs have been downloaded from my site. 120,000. I never expected that. But I guess if you offer something for free, it goes viral. And if people find it of value, they download it and they use it and they tell their friends. And so that's what ham radio is all about. That's what it should be. We need to support each other, mentor each other, Elmer each other. No such thing as sad hams in my world. So I design efficient and effective portable antennas for the every ham, and I'll talk about that. In other words, out of bits and bytes that you probably already have in your ham radio stuff box that focus on performance, elegance, and convenience. So I am a geek. So when I think about a new antenna, I do spend about 5% of my development time trying to understand the theory. I want to understand the field theory, which was a very tough course to take in engineering school. Let me tell you, that was the toughest course. But I'm only about 5% of my time. And I'm not going to push it on people unless they ask about it. But I spend a lot of my time, in particular, early on, right around 2020, when I discovered 4NEC2. Since then, there's some easier programs that have come out, but I learned on this one, and this is the granddaddy, and this works so well. I have a lot of creative ideas that I like to come up with in tennis, and so I test them out. In fact, this morning I spent 3 hours improving one of my existing antennas, pulling out another extra plus dBi gain and directivity. So we'll talk about that a little bit later. But I do a lot of computer modeling, and I love that. But where I spend the bulk of my time as I develop an antenna is in my antenna proving ground here in Silicon Valley, and maybe not so much in Las Vegas, but in Silicon Valley, we live on postage stamps. I mean, we're talking quarter acre at best. So right here next to my solar panels is my antenna proving ground in the backyard. And I spend hours and hours and hours of time taking what's in the virtual world and bringing it to the real world. And there's a difference. I mean, you can try to program a lot of the ground variables, but you can't program everything specifically. You can't program near field surroundings, velocity factors, and everything else that happen in the real world. So I have to spend a lot of time transferring the model in here to what the real world is. And there's typically a difference. There's a difference, but it's a lot of fun for me to do. But where I get the bulk of my feedback real world evaluation, I call it, is Parks on the Air. And that's one of the reasons I love Parks on the Air. I've used my hunters as guinea pigs, testing antennas, AB, sometimes ABC testing antennas, getting their feedback, and it's really, really been valuable. So that's how I started with my antenna journey about 5 years ago, and I'm continuing to use not only POTA because I love it, but because I like to interact with the hunters, and I've gotten to know so many over the years. Maybe some of you in the room as well. I recognize a couple of those call signs. All right. So when I talk about the every ham, I'm talking about let's not have to go out and buy fancy parts and pieces. Let's hope that you have most of this stuff already in your ham radio stuff box. I know I have 3 or 4 boxes. My wife hates them, but I got them. And I keep a lot of my parts and pieces in there, and I call them my Tinker Toys. You remember Tinker Toys? They came in that little, that big, long, round box and with a little metal cap on. I'm really dating myself. That was back in the 70s, I think. But I love that. And I loved all the straight line pieces and the hubs and all the other things you could add to it. Well, that's what I call antennas. They're Tinker Toys, right? And so I have all these things in my stuff box, and I use the same parts. I use the same parts for all of my antennas. So if you have some of these parts or you want to pick up a few, you can build any one of my antennas with the same parts. For example, they don't allow wires in California in trees. I don't know if that's true in Nevada, but so all of my antennas use 25-foot or 17-foot telescoping whips. Quite frankly, that's the most convenient. Sometimes you have to shoot these wires into over tree limbs, and sometimes you have to throw them over there. It's sometimes it's not good, but they don't allow them in California parks anyway. So I use telescoping whips. I love these little mirror mounts, CB mounts, truckers mounts, whatever you want to call them. They're really inexpensive. I'm sure you have at least one of those. And ABC, always be choking. How many conductors does your coax have? 2 or 3? It has 3. You have the center conductor, you have the inside of the shield, and if you don't use a choke, you have the outside of the shield as your third conductor, which is another radial, another counterpoise. It's just going to create common mode current, RFI down the line, back at the rig. You don't want that. So always be choking, A, B, C. So I always use, and my preferences are these coax wrap toroids, not the beads. If you use the beads, you got to use at least 7, preferably 14. I see some guys just come out with 3. They don't do much at all for you. You want a good coax wrap toroid, a mix 31 toroid. Okay, and so to support all this, you got to put them on a tripod. I've seen all kinds of tripods. I like these really lightweight aluminum ones that photographers use. You can get them on Amazon pretty cheap. Or you can build, and I've done this too, the PVC tube. I like the furniture grade, where you put them on a metal spike in the ground. If you can, go to a park where you can put it in the ground, that's very efficient, very easy to do. So tripods or tubes/spikes, going the wrong way. There we go. And if it's not a quarter wave antenna, you're going to have to match it. You're going to have to match it. And these are called ununs and balance. Unbalanced feed line, which is coax, to an unbalanced antenna, like a quarter wave, anything that's not a dipole for the most part. So ununs, balance, 9-to-1s, 4-to-1s, 49-to-1. I like this one from 10 Tennis. That's on eBay. A guy in Tennessee builds a pretty good one, but it's not quite as efficient as these on my antennas, the 56-to-1. So you got to have some of those to build some of these non-quarter wave antennas because they're really cool to play with. And I try to pick units, ununs, transformers, same thing, that have low insertion loss, especially this one. This one has very low insertion loss for a 56-to-1. Okay, so then you got to have wire. And, why tangle up the wire? You can buy speaker wire. Speaker wire is great. It's inexpensive. But I put in some money up front and I bought some spools of silicon coated wire. And boy, oh boy, all that spaghetti in the field, it just kind of unravels easily. So I like different colors, high visibility colors like orange and yellow. So I just bought some spools of that on Amazon. Again, pretty cheap. Now, some of my antennas, in fact, I think all of them have a component that you don't want any connectivity in the line. And I'll show you an example with the Performer. So I like Weed Whacker line. It works. 2 to 4 inches. You can use paracord, but I like weed whacker line. It's that nylon cord you kind of put in your weed whacker if you do your own lawn, like I do. And it's really inexpensive and it works perfectly to non-conduct, which is what you want in some cases. And I'll show you what those are. Now, to attach wires and nylon cord to antenna whips or to your CB mount, I like Mueller clips. These are, some people call them battery terminal clips, the 10 amp, 20 amp, whatever you have. They work great. They work really, really well, and you can attach your wires or your nylon cord in there. I also discovered a couple of years ago Wago connectors, or as the Germans say, Vago connectors. Vago connectors, they're amazing. These two little levers lift up and you can insert your wire in there and they clamp down and you can't take them apart. And it basically connects those two wires. And that's really important because a lot of my antennas, actually all of my antennas, are band linked to change the size of each of the, I have all the bands figured out for you. So just to kind of wiggle them together, if you want to change from the 15 meter to the 17 meter band or 20, whatever, you just use these little Vago connectors. And again, they're pretty inexpensive, but they last forever and they're very, very strong. And instead of inserting bare wire in there, I always put these little wire ferrules with a little crimper. You strip your wire just a little bit, about an eighth quarter of an inch, and you put them in here. And this little thing is like a hexagon here. It just crimps it. And boy, does it crimp it tight. It will not come out. And then you insert that little tube right into the Vago connector and it's set to go. Really, really strong. Big recommendation for Vago connectors and wire ferrules. And I talk about them in all my PDFs, so you can find out more about them there. Okay, I mentioned I started with the Performer portable elevated resonant antenna for myself. That's a quarter wave antenna. I then came up with an end-fed half wave vertical using a 25-foot telescoping whip for a very low takeoff angle, and also great for DX when the bands were open for DX, not so much these days. I then came up with an off-center fed because I wanted a 20-foot version, a 20-meter version of the half wave antenna, and that's an off-center fed using a 25-foot telescoping whip. Then I wanted more gain, and you're going to need it, my friends, because we're heading towards the solar minimum in 2030. Just about 4 to 3 years away. So you're going to need more gain to be heard. We're all going to be crammed into 20 meters and 40 meters and maybe 30 meters. So I started adding parasitic, in this case, a parasitic director to the dominator for lots of gain, parasitic director to the challenger for lots of gain. Each one of these has its own PDF, by the way. I also did the same thing for the performer. So you can put two performers together. And parasitic just means you feed one antenna and the other one is not fed, it's not hooked to coax, but it sits a certain distance away from the radiator and it's a certain length, either longer if it's a reflector or shorter if it's a director. I then came up, I had a lot of people say, you know, I'm an ECOMS, I need an NVIS version. So if you have the performer, I figured out a way just to add one wire to it to make it an NVIS antenna. We'll talk about that very briefly. Probably the fastest, most downloaded antenna that I just introduced, it was in March, April, I believe, called the Marauder. I've always loved Moxons, but they're, you know, you got to keep them a half wave up and they're single band. So I came up with a vertically polarized Moxon inspired antenna using two telescoping whips and two cross wires. I was working on it this afternoon. It gets up to 4 dB gain, forward gain, very directional, 19 dB front to back. This thing is probably my favorite gain antenna as we go into the solar minimum. You're going to need that extra power. That's called the Marauder. And then because we're going into the fall months, I decided to come up with a compact inverted V. I'm going to call that one the Nether. I'll introduce that this fall. I'll be introducing probably next month, called the Thruster. It's a triangular loop, which basically is similar to the Performer, but it just creates a loop, a triangular loop, a right triangle, not a delta loop, using only one whip. So it's pretty cool in that regard. I also always love the half square antenna for DX antenna. So I'll be introducing that one later this fall as well, the Hammer half square. And then, of course, there's got to be a parasitic, I think it's a reflector. Yeah, parasitic reflector that I'll be introducing with the Thruster coming up later this year. So lots of antennas. If you're into this kind of geeky stuff, these are always free. Go to the website. You can download your favorite. Okay, I'm looking at the clock. I've got 15 minutes, so I'm going to focus on just a little bit of antenna fundamentals, just to kind of keep the geeks happy in the audience. One of the most important things we've talked about is resonance, resonant antenna. And for those of you that passed your exam or will be taking an exam, you've seen this equation. Z, impedance, is equal to R, real resistance, plus J, square root of -1. Don't worry about that. Times X, reactance, capacitive or inductive. A resonant antenna is when the capacitance offsets the inductance, so it gets close to zero. It's never exactly zero, but it gets close to zero. That's called a resonant antenna. And what is special about a resonant antenna? Your radio, when you have a resonant antenna, sees two resistors in series to ground. That's a resonant antenna. That's it. It's not complicated. Your transceiver sees two resistors in series to ground. And just like everything else in life, there's a good resistor and there's a bad resistor. There's a yin and there's a yang. The good resistor is radiation resistance, and that's kind of built into your antenna configuration. If you got a quarter wave, it's about 37 ohms roughly. If you got a center fed, it's almost double that, 70, 72 ohms. That resistor is what your current uses to radiate electromagnetic waves in all directions. That's the good resistor. But just like everything else, there's got to be a bad one. So you know that there's a good one. And the bad one is called loss resistance. That includes losses that when you, in your antenna structure, I'm speaking specifically about antennas now, when you apply current to your antenna, it heats up conductors, insulators, loading elements. That's why I don't like coils. If you don't have to use them, don't use them. But by far, the biggest culprit is the ground. You're heating up ants in Nevada. You don't need to do that. And I'll show you why, because that's wasted energy. Now, what makes this very interesting, and this is what I learned when I started doing my own research, is radiation efficiency. And that's one of two primary things for you to consider when you look at your entire antenna system. Radiation efficiency of your antenna and also the loss that's in your coax. Those two things contribute the most to getting out a weak signal. So let's focus on radiation efficiency. Now, radiation efficiency, it's a complicated derivation, but it comes down to one very simple equation. Radiation efficiency is the good resistor, radiation resistance, over the sum of radiation resistance plus loss resistance. So looking at this equation, it's simple. Just you want to minimize your loss resistance. You don't want to have losses into the ground. You don't want to be heating up ants out there in Nevada. So let's take that and let's go to one of my geeky heroes, John Oppenheimer, who did a lot of research, and he actually measured the loss resistance of a quarter wave antenna radials laying on the ground. Radials laying on the ground. This is amazing. And this opens a lot of eyes. He figured it out. Now you can't measure it directly with a gadget. You have to calculate it, but he did an amazing job, and that's why this study, and it's on the web, vertical antenna ground radial loss study. He did an amazing job. And basically, if you go out there with your quarter wave and you put two radials on the ground, they call them surface radials. You just lay them on the ground, portable antenna, not buried. Buried is good, but that's not portable. So you just lay them on the ground. All right, that's 79 ohms of loss resistance. Where you go, well, that's not too much. Plug it in the equation. 37 ohms over 37 plus 79 is what? 32%. So if you apply 100 watts to that antenna, you're only going to radiate 32. That doesn't sound too good. But you say, don't worry, Greg. I put down 4 or I put down 8. I put down 8 surface radials. A lot of guys do that. I'm doing just fine. No, you're not. 4 radials, 37% efficient. 8 radials laying on the ground, one at each compass point, one in between, 47% efficient. In fact, it takes 86 surface radials, 86, to get 90% radiation efficiency. Most commercial antennas are sitting around here, 30 to 47%. What if I told you, rather than laying down 86 surface radials, you just elevate 2? You elevate 2. You elevate 2, it's about a loss resistance of about 4 ohms. You plug that in your equation. 37 over 41 is what? 90%. Here's Greg with his two elevated radials next to let's see, who can I pick on? Ron. Ron's out there with his 8 radials surfing, laying on the ground. He's so proud because he has a perfect SWR 1.01. 47 watts he's radiating. I got two elevated radials. I'm radiating twice that. I already have a 3 dB advantage. We're using the same transceiver, same model, but I got twice the radiated power that he has. That's called radiation efficiency. Uh, for an example, let's take those same numbers. This is, we just looked at the last, on that chart, efficiency 32% if you have 2 radials, 37% if you have 4, 47% if you have 8, 57 if you have 16. How big a power amplifier do you need to match my performer with just 2 elevated radials? All right, let's say you're out there. Let's look at the whole antenna system, and this is from my primers too. Let's have 50 feet of LMR 400. That's really good coax, low loss coax. And let's say you have an SWR of 1.5. That's pretty reasonable. You don't need a tuner with an SWR of 1.5. Please don't use one. All right. If you got 8 surface radials like Ron has out there, and he's only 47% efficient, once you take into account the loss in the cable plus the SWR, which doesn't technically lose it, it just bounces back and forth inside the cable, which then loses more because of the cable loss. You're only going to radiate about 39.4 watts. You're going to put in 100, you're only going to radiate 39.4 watts. But here's Greg over here with his performer, and let's say I have my radials opposite each other to make it omnidirectional. You would need to match me with the same coax and the same SWR, 194 watt amplifier. 194 watt. And then if I put my 2 elevated radials at 90 degrees to give it some directivity, just a little bit, you're going to need a 241 watt amplifier just to match my performer with 2 elevated radials. Why throw all that power away? You're wasting, watts are expensive. You're wasting your watts and you're heating up those amps. You don't need to do that. Okay. Then there was a guy, another one of my heroes, Rudy Severance. He went to a sophisticated RF test range, which was calibrated. He used some very sophisticated, I think it was like a HP, it was an HP 8753 VNA, cost about $50,000, a lot different than those little $100 ones you buy on Amazon. But he did a very sophisticated, he went out about, I think it was about 1.8 wavelengths away. And he started saying, all right, well, I'm going to measure the power output of my quarter wave 40 meter antenna with 4 quarter wave radials laying on the ground and measure what the performance is or what the signal power is. And that's going to be my 0 dB point. So he normalized it to 4 radials on the ground. And as he went to 8, 16, 32, 64, you see this curve, and it makes sense because you're improving the RF circuit. You're allowing more of the radiated RF to go back to the feed point to get re-radiated. Okay, that makes sense. We've seen that kind of chart with an inflection point around 32. Then he said, I'm going to do the same thing. Here's my gain improvement here. And instead of increasing the number of radials, I'm just going to start to elevate them. I'm going to take those 4 radials, not add any more, but I'm just going to elevate them. 6 inches off the ground, he got a 5 dB improvement. 6 inches. And he went all the way up to 4 feet off the ground. He got more than what he had with 64 radials on the ground. His conclusion, and he ran this test multiple times, and this has been reprinted many, many times. I think Step IR uses this a lot in their advertising. 4 elevated radials at a height of 4 feet are equivalent to 64 laying on the ground. So he proved it. It was just amazing. All right, I got 5 minutes. All right, I better keep moving. So here's your dipole. All right, so why is this? Let's figure out why this happens. Here's your dipole, right? Half wavelength, fed in the middle. When you look at how the current is distributed over your dipole, it looks like this. The maximum's in the middle, and your ends are at the minimum, and the voltage is just the opposite when it's a resonant antenna. Because when it's a resonant antenna, you get a standing wave of current and voltage 90 degrees out of phase, and that's what it looks like. Here's your voltage maxima on the ends, your current maxima in the middle, and let's use Ohm's law. As we go out, you have decreasing current and you have increasing voltage. What happens to your resistance or impedance in this case? it goes up, right? Remember, equals V over I, or in this case, Z impedance equals V over I. Uh, because it's purely resistive, the impedance as you go out towards the end of that dipole gets very, very high. That's why the middle of the dipole, you can just run at 70 ohms. You can just run it straight through a current balun. But if you're off center fed, typically about 80% of the way down the line, you use your 4 to 9 to 1 unun. That's the impedance match I talked about. Or if you go towards the end, you got to use something like a 49 or 64 to 1 because it's in the thousands of ohms, right? Okay, now let's take that dipole and let's put one end up like a quarter wave antenna. And here's your radials, the other half of your antenna, right? It's just a dipole, except it's bent, right? All right, here's your current distribution. It's basically the same thing. It's no different. Your maxima, current maxima. And remember, it's current that radiates, not voltage. Your current maxima is right there in the middle at the feed point. Now let's talk about capacitance. You probably learned a little bit about this in your science class, maybe in high school. I know I did. Capacitance is equal to a dielectric times the area of the plates. We don't care about those so much, but it's over distance, the distance between the plates, right? So in other words, using this equation, capacitance and the distance between the plates are inversely proportional, meaning that the closer the plates are, the greater the capacitance, or the further the plates are, the smaller the capacitance. Well, to help you understand why elevating radials is the right thing to do, capacitance and capacitive coupling is not your friend. You don't want it. You don't want it. So imagine the quarter wave radials as one plate of the capacitor and the ground being the other plate. Obviously, when they're really, really close, capacitance is high. The ground is sucking up all that potential radiated energy that could be going out into the ionosphere. Instead, it's heating up ants in Nevada. You don't want that. But as you elevate it, the capacitance goes way, way down. And then all of a sudden, now these radials can return that current back to the feed point, back to the coax to get re-radiated out again. And so that increases your radiation efficiency. Straightforward, right? Okay, in my last 2 minutes, I will going to talk about some of these antennas very, very quickly, and let you give me a little bit more time. The Performer is the one I've been talking about tonight. It uses your telescoping whip. It uses your mirror mount. You can put it on a tripod or a PVC tube. Always be choking, ABC. You have two elevated radials, which I figured out how to resonate in the center of each of the bands. So you don't have to figure it out. I tell you how long to cut each one of these elevated radial segments. And the way you change bands is you just keep, adding more and more segments all the way out to 20 meters. And then I figured out you don't need to keep moving these elevation stakes. These are just driveway snow markers. That's all they are. You can get them really cheap on Amazon. You can use that non-conductive weed whacker line I talked about. When it's out here, your antenna sees the entire linked radial, so you're operating on 20 meters. But if you want to switch to 15, you just unhook it there and you put it just after the 15-meter radial, and then your antenna will see all that length, and then it sees that and it goes, oh, that's the end of the radial. I'm going to operate on 15 meters. And then if you're a CW digital guy, you make your whip a little bit longer because that's your variable. If you're a sideband guy like me, you make it a little bit shorter and you're all set. And you get reasonable directivity, some modest directivity when you put your radials at 90 degrees, or if you put them omnidirectional, which is the way a lot of people like to use them, you get also great omnidirectional quarter wave, and it radiates about 24 degrees, which is a perfect continental regional antenna. It's great for parks on the air. Radiation pattern, when the radials are at 90 degrees, they look like this from the side. Isn't that cool? These are 4NEC2 graphics. When I saw this, I go, wow, I got to build this antenna. And here it is from the top. The purple and the red are the strongest radiation of the antenna. Here's the orange, the bright colored silicon coated wire. Here's the Waco connectors that I talked about and the wire ferrules with a little crimper I mentioned. These are the weed whacker segments that you move up and down the radial to change bands. I wrap them up with a little Velcro strip when I take them to a picnic table, or if I go into my ICOM 705 backpack, I put them on a kite winder with my Rig Expert stick and my Byberry multi-tool and my coil, M coil for 40 meters, and I'm all set to go. It's fantastic. And this is showing you the forward gain on a Cartesian coordinates of each of the antennas versus the radiated energy by degree. So you can see when you have your radials at 90 degrees, you get a little bit more gain and a little bit more directivity. So it's something to consider if you build the performer. It's really cool that way. But this is reality. This is at a POTA park. I want you to notice two things. One, how well it tunes on each of the bands. But two, look how broad banded it is. Look how broad banded on every single band, 20, 17, 15, 12, 10, and 6. And let me tell you, my friends, any SWR 1.5 or better is fine. You don't need a tuner. I even go up to 1.7. You don't need a tuner. Avoid SWR derangement syndrome. You don't need to have 1.1 or 1.2. It's great if you get it, but that's just matching. The antenna radiation efficiency is far, far more important. And then I have this NVIS version, and I'm going to finish here because I see my time is running out. I have an NVIS version that if you ever want some high angle gain, basically from here over to the right is just your regular performer, but you put two radials to one elevation pole. And then I figured out you put another wire off a very short telescoping whip, about 34 inches. So you, in essence, what you get is you get an adjustable low to the ground dipole, which is perfect NVIS, 86-degree NVIS radiation. And look at this big, beautiful bubble of radiation. Ecom guys love this on 40, 30, and even 80 meters sometimes. But also on 20 meters and above, it's not NVIS, but you get high angle radiation. So you can get shorter range contacts. I work inside California with this antenna all the time because you get inside your skip zone. And it gives you very broad range of coverage from 50 positive dBi coverage, but 50 degrees on up till it's almost near vertical incident. Then I have a phased array I talked about. I'm running out of time, so I'll just show you some pretty pictures. This is what it looks like. Very directional, about double the performance of a single performer. I also have a couple of verticals, off-center fed and end fed, and I have different, and I show you in the PDF, you can have different ununs for greater efficiency if you want. You can see the off-center fed looks like this. The end fed, a little lower angular radiation, about 18 degrees for fantastic DX coverage. So that's called the Dominator, and that's what they look like, one relative to the other. And then this antenna I talked about that I love, and I'm going to wrap up on this one. This is the Marauder. I've always been fascinated by the Moxon antenna. It was invented by Les Moxon, a brilliant guy, British engineer back in the, I think it was the 80s. Yep, the 80s. And basically, it comes typically in two forms. The tube form, and they have to be a half, just like a dipole, they have to be a half wavelength up for top performance. It basically has this, and I'll click to this. It has a bent dipole radiator in this half, and you can see, you probably can't see it on your screen, but it's a little thicker here. That's a non-conductive segment, and that separates the bent dipole radiator from the parasitic reflector, which is also bent. So I love this antenna, but it's not really practical to take portable because you have to get it up, especially on 20 meters. You're talking 33 feet, and that's tough to do. So I said, I'm going to create a different one. So I came up with a vertically polarized, Moxon inspired, and instead of feeding these bent dipoles in the middle, I feed them at the end like an end-fed half wave. So if you look at this, I use two telescoping whips, two identical cross wires. The whip in the back's a little bit longer to make the reflector big, but this is your bent end-fed half wave radiator going up this whip and then continuing through this cross wire. And then look at that. There's a non-conducting segment, so it stops right there. And then this is your other telescoping whip, and these are 17-foot whips. They don't have to be the 25, but you can use those as well, which starts here and it goes all the way there. And then there's another non-conducting nylon segment. So this becomes your end-fed, half-wave, bent, Moxon-inspired vertical antenna. But look at the gain. The average gain across all the bands, and that's why I'm taking this antenna into the solar minimum, over 3 dBi forward gain with 18 dB front to back. And that's just 20 meters. On average, 3.6 dBi across all the bands, 18.7 dBi front to back. That is significant. And why is that significant? Because you can point it in the direction that you want to get your signal out, but you can also reject signals from behind you or a noise source that you have nearby. It's a fantastic antenna, and this is what it looks like on 4NEC2. And you can see it's very, very directional because the purple and the red are your strongest signal areas. Okay. So with that, I'm going to skip, and this is coming out. This is the triangle. It's a right triangle. It's another cool antenna. I'm going to skip that. This is the half square. It's also coming out later on this year. This one has a very low angular radiation and 2.6 dBi, so still very good gain using 2 telescoping whips. And then I have my compact inverted V. This is going to be a lot of fun, especially if you want to operate 80, 60, and 40 meters this fall, because, you know, the upper bands probably aren't going to be too good. They're going to start to get worse as we move into 2020. Okay, so you can build these things. I promote it. I want you to do that. I had quite a few emails from folks saying, I don't have the time. I'm too old to build my own. So can you make one for me? I said, no, but there's a guy in Chicago who has a technology company who hand makes all these antennas. He's on Etsy. He's called J Systems. He's got over 320 products sold already and 85-star reviews, 100% 5-star reviews. So high quality handmade antennas, accessories. He also puts together kits if you want to save money, where he kind of sources all the parts for you already. You just have to put it together. And he also does custom ideas and antennas. So by all means, you can reach out to him. So those are all my antennas. I know I went through it quick, but I wanted to finish before, I guess, 8 o'clock now. And don't forget my website. Everything's free on the website. All the antenna designs, all the educational material, the primers, the geek email list. If you want to get some of the stuff on a monthly basis, by all means, get on that list there. Or send me an email if you have a question, greg@kj6er.net. And with that, I will say thank you. And I apologize I went fast, but there you go. We got it. And I'll stop right there and I'll answer any questions if you have it.
Go ahead.
Sure. I'm wondering, first of all, I'm not really an HF guy. I'm more VHF, UHF, SHF. I'm wondering, first of all, what antenna designs you have, people like operate digital or 2.4 gig that are good. I also am curious about if you've done anything with fractal antennas. And I saw someone who designed a fractal antenna for 2.4 gig. It's kind of like a feed horn almost for a dish.
Oh yeah, I've seen those.
What software you use for fractal design?
Yeah, you know, I tell you, I haven't. That is my next focus is to get into VHF, UHF. I do have an ICOM 9700, which I love to use on all the nets and things, but I haven't designed any VHF, UHF antennas. I think fractal antennas are really cool. I want to learn more about those. So unfortunately, I can't give you any definitive answer to your question, but I do agree with you. It is cool tech, and I want to learn more about it, especially as the HF bands kind of dwindle as we go into the solar minimum. The upper bands will dwindle. So people will be on 20, 30, 40 meters and VHF, UHF.
I have one other question for you. I'm wondering if you have done any investigation with using standing waves generated by RF for doing any kind of levitation, which I have seen people doing with other kinds of standing waves that were not RF based.
Levitation of what? People?
No, things like marbles. I mean, I'm scaling up to have your thing. I wasn't talking about people, but they're like small things, but they're using standing wave rated. There's physics labs.
Yeah.
They're using standing wave.
You know,
small things.
Yeah, you're on some fringe science there. I have not researched that, so I can't answer that. But that sounds interesting. I don't know what you'd use it for, but I think it would be a cool experiment. So again, I haven't looked into that myself, so I can't really answer the question, but it sounds cool. I'll have to look it up.
It's absolutely real. I mean, it's not.
I believe you.
Yeah, so
not people.
That's definitely the real physics.
I believe you. Yeah, maybe that's how flying saucers work their way across Nevada and New Mexico.
Yeah, there you go. Greg, thank you very much. We really appreciate it.
I know you have to go. Okay. Thank you very much. Don't forget
And I'm
KJ6ER.
sure that we'll want to invite you back after you get those new antennas built, and we'll see them up on your website.
Yes, yes, they'll be on the website. And give me just a little bit more time next time. Maybe start me earlier and I can go into more detail. Get really geeky.
You got it, will do.
All right, I'll let you
Thank
go.
Thank you.